All right, you guys, the next chapter or unit we're going to be moving into is called the right triangle relationships. And we're going to be dealing all with right triangles this unit. So one of the angles is 90 degrees. So the first thing we're going to start off with this theorem called Pythagorean Theorem. And Pythagorean Theorem was figured out many years ago by a man named Pythagoras. And we'll do some things in class to prove the Pythagorean Theorem, but just to start off with what the Pythagorean Theorem even is. So I want you in your notebook to write Pythagorean Theorem. And the Pythagorean Theorem states that a squared plus b squared equals c squared. And this is always going to be true for any right triangle. And that's super important. It doesn't work if it's not a right triangle. All right, so the next thing you know is what are we talking about with A and B? So let's draw a right triangle. A and B, these are considered the legs. Okay, and when I show you in class how you prove the Pythagorean Theorem, these two will always make up the right angle. Across from the right angle, this is C, and we call this the hypotenuse. It's a funny word, I know. And the hypotenuse is always the longest side of a triangle. And it's always across from that right angle. It's always the diagonal. I mean, sometimes your triangle can be like this. Here's your right angle. The hypotenuse is still always across from the diagonal. All right, so we have the Pythagorean Theorem. A squared plus b squared equals c squared, and it's only good for right triangles. So let's actually go into solving some things with this. And a lot of times we use distance with the Pythagorean Theorem, and that is how we will use this in like real life. And you'll kind of see this one is more of a real life than some of the things we've been doing. So let's say we have, this is our example 1. We have 4 and we have 3. And we are trying to find x, okay? Now, sometimes we don't always look for x, or we don't always look for c, but this is what we're doing right here. So this is how we're going to set this up. It doesn't matter which one is a, it doesn't matter which one is b. They can be interchangeable for the legs. So we would write this just like our formula shows up here. We have 4 squared. Move this up a little bit. 4 squared plus 3 squared equals x squared. So let's do the math here. 4 squared is 16 plus 3 squared, 3 times 3 is 9, equals x squared. So we're literally just solving equations. So 16 plus 9 is 25. 25 equals x squared. Now, when we solve equations, we always have to do the opposite operation. If it's multiplication, we use division. If it's division, we use multiplication. So we have to think to ourselves, what's the inverse operation, or what undoes square? What is going to undo a square? What's the opposite of squaring something? Well, the opposite of squaring something is taking the square root. So we're going to take the square root of 25. So what times itself gives us 25? And that's going to be 5. So x equals 5, which makes sense because this hypotenuse has to be the longest side, and 5 is the biggest number here. All right, let's try another one. Let's do 8 and 15. And here's x. Now again, we're looking for a hypotenuse. We're looking for the longest side. We always have to decide, are we looking for a leg or are we looking for a hypotenuse? Here we're looking for the hypotenuse. So we can say 15 squared plus 8 squared equals x squared. You could have said 8 squared plus 15 squared. It doesn't matter. So 15 squared, 15 times 15 is 255, plus 8 times 8 is 64, equals x squared. Running out of room here. I'm going to add these. So I have 289 equals x squared. And again, we get rid of this squared by taking the square root. Okay, and let's show that in the calculator. I wanted to show you this. So if you have this kind of calculator, you're going to type in 289, and you hit the square root button, you get 17. If you're using like a more fancy calculator, same thing. You're going to type in 200, what's blurry? 89 square root gives you 17. So x equals 17. It will not always be a perfect number. All right, let's do another example here. This might look a little bit different. Let's say we have this. All right, so we have a triangle here. We have 10, and we have 24, and we have x. Now here's my right angle. X is here. So are they asking us for a leg or a hypotenuse? Well, I already know the hypotenuse. The hypotenuse is 24 this time. So when I set this up, this is actually C. So I have A, which is 10 squared, plus I don't know B, or I don't know the other leg. I can put B squared, I can put X squared, doesn't matter, equals 24 squared. So the only difference this time is we're solving for one of the legs. The leg, remember, connects to the right angle. So let's go ahead and do this. So 10 squared is 100 plus x squared equals 24 times 24 gives me 576. Okay, now I have to solve this. I have to get x by itself. Well, what's standing in the way of x is 100. So I'm going to subtract 100 to both sides. So I have x squared equals 476. Now again, what undoes x squared? Take the square root of both sides. I take my calculator. I go 476 square root. Oh, not a perfect square. We are going to round to the nearest tenth here. So I'm going to say 21.8 because the 1 makes the 8 stay the same. So x is approximate, not equal, so I make squigglies. 21.8, and I'm going to put units because I don't know if it's centimeters, meters, or what. So this time we had one extra step. We had to subtract instead of add because I was looking for a leg. Now let's do another one here. 15, 9, and x. Why don't you go ahead and see if you can figure this one out on your own this time. So you should have had a minute to do this. Here's my right angle. My two legs are 9 and x. So again, I'm trying to find a leg. So I have 9 squared plus x squared equals 15 squared. So 9 squared, 9 times 9 is 81, plus x squared equals 15 times 15 is 225. Now I'm going to get x by itself, so I'm going to subtract 81 from both sides. X squared equals 144. Take the square root of x. I already know the square root of 144 is 12, but if not, you can type it in your calculator, and it's 12 units. So there's the basics of Pythagorean theorem, and we will move into more eventually.